All right. Live on TikTok, live on Facebook, and we are live on YouTube. All right, welcome back. It's Maddie Adams. So first off, I just wanted to say a happy Veterans Day to everybody in the United States. To my fellow veterans out there, thank you for serving. Um, and also, I got a new cat, so hopefully he will be making a guest appearance. His name is Sir Leonardo da Kitty. All right. So it's been about 3 weeks since my last live on YouTube where we talked about comets. So I wanted to just start with an update on 3i Atlas since 3i Atlas has kind of gone past its come out from behind the sun now. So let's chat about that real quick. So 3i Atlas plus Swan, Lemon, K1 Atlas, T1 Atlas, we have just an entire platter of comets in the sky for November. So it's been pretty awesome. But 3i is the weird one with the really weird perihelion. Um, so let's take a look here. Just want to take a look at some images. Now, there haven't been really great images of 3i Atlas because of the fact that it's just not nearly as bright. Now, it did recently um, do a lot more brightening, so we're going to be talking about that in a second. But compared to, like, I have seen just some stunning images of 2025 A6 Lemon, and I just don't think we're necessarily going to get those, and I'll tell you why in a little bit. Um, like I said, so 3i Atlas is the third interstellar object. It has an extremely hyperbolic orbit at about 6, which means it's just shooting straight through. I just want to check my sound real quick here. Okay. So it hit its perihelion on October 30th at about 1.4 AU. And if you want to know more about just the basic details of it, I talked about that 3 weeks ago in our live. So, but the weird puzzle is that in early October, it was at a magnitude of about 11.5. And in a couple of weeks, its magnitude increased greatly by about 10x in weeks to a magnitude of about 9. So it got a blue glow from CO2 and CO gas overpowering the dust. And this was kind of interesting. It made the news, and a lot of people obviously started speculating about all kinds of interesting stuff. Again, is it aliens? What's different about this object than other objects? So post-perihelion, it has dimmed back to about a magnitude of 9.8 around November 9th. So like I said, this is why we're not going to see those stunning, insanely bright images that from amateur photographers like we're seeing with Lemon. And like I said, I would really recommend, if you want to see some great pictures of Lemon, just check out Chuck's Astrophotography on Facebook. I've never met the guy, but I came upon him just from these wonderful Lemon images that he's taking. So anyways, let's go. Just want to bring up a new site here. Like I said, I hope everyone's having a great day. Happy Veterans Day to all the veterans out there. I don't know why I brought this up. Oh, this is just the Hubble Space Telescope site. Sorry, wrong site. Okay. So, now let's talk about the outgassing and the spectra. So, August 6th, we had a CO2 dominated coma. We had a low water vapor and ice. And that's one of the weird things about 3i Atlas is that it has a very low amount of water vapor compared to what we are used to seeing, right? And that's what's another thing that's kind of made people speculate a lot. It's got evaporative cooling. So it has fast CO2 blasts. No water fireworks like Lemon, though. Like I said, that's why we're not getting the brightening. And we're going to talk about how we classify comets versus asteroids in a minute, and sort of how humans like to just define things and put things in a box. But really, asteroids and comets, they're just kind of all different objects out there, and we classify them based on how much of different elements are in them, how dark they are, and things like that, right? So just keep that in mind as we move forward. So Avi Loeb mentioned something about the non-gravitational acceleration from 3i Atlas. And, this is something to kind of suggest that perhaps, it's an alien spacecraft. But I just wanted to note that the non-gravitational acceleration that was observed for 3i Atlas was about 2 times 10 to the negative eighth meters per second of acceleration. So that's weaker than a butterfly landing on a marble. We're not talking about jet thrusters here. We're talking about a very, very, very small amount of non-gravitational acceleration here. And that's based on this paper that I'll link in the description later. So this is the actual paper if you want to read it. This is from, I don't know how to say this, arxiv.org it looks like. So it's arxiv.org. And so it kind of just goes through comets and planetesimals are theorized to form in large numbers during the acceleration of planetary systems. Many of these small bodies, composed of ice, rock, and dust, are subsequently expected to be ejected into interstellar space through gravitational encounters. And due to its faintness and short observation window, spectroscopic characterization of volatiles from 1I Oumuamua proved elusive, so the composition of this object remains highly uncertain. Then it goes through some more stuff about Borisov, and then starts getting into observations of 3i Atlas. So, like I said, I'm not going to read the entire technical paper here. I'm sure a lot of you guys have probably seen these images that, like I said, if you're looking for these really awesome kind of bright amateur astrophotography images, I don't know if we're really going to get them. Kind of our last chance is when it flies by Jupiter, and we're going to use some of our instruments around Jupiter. So we'll see. But anyways, so that's where we kind of get to the competition of the composition of this asteroid. So we're talking about a D-type asteroid here. And what that means is that it's dark red and carbon rich with a low albedo and an outer system origin. A reddish coma from tholins, which is irradiated organics. What's odd, like I said, about 3i Atlas is the nickel and iron oddity. So it has higher nickel vapor, no iron detected, and the ratio is, so basically it has more nickel than what we would normally see, but the ratio is kind of within normal limits, not, like alien hull levels here that we're talking about. So it's likely a rocky rogue based on dry fragment from disrupted planetesimal, eons in a void, low ice, CO2 crust. So we're talking about, and like I said, when we're talking about comets and asteroids, just keep in mind that they literally could just be anything that has broken off or crashed and is flying around in outer space, right? So we create different classifications based on what they're composed of, but keep in mind that these really could be anything. And like I said, we classify it as a comet, but really it might end up being, declassified from a comet based on the observations and how much water ice is actually in it. So these are some new observations that we have here. I'll take a nice little zoom here for everybody on YouTube that can see me sharing the screen. If you're just watching on TikTok or you're just watching on Facebook, you can't see my screen share, unfortunately. So TikTok, I'll be able to start sharing my screen. I just have to go live from the desktop a few more times. So, but yeah, so why do we have all these blurry and no high-res pics? Like I said, the solar conjunction was at October 21st. The glare blinded Earth scopes. So we had our MRO on Mars, the HiRISE, which took October 2nd raw images, and I think I showed you those 2 weeks ago, but they're just not super impressive because the HiRISE isn't really meant for that type of imaging. So obviously a lot of people are accusing NASA of sort of a cover-up. Now I will say that if they found anything extremely weird, it is likely the governments wouldn't want to tell us about it, right? But a lack of information doesn't always necessarily mean a conspiracy. Yeah, that's the one we were just looking at. So, like I said, we like to draw lines with comets and asteroids and exactly what they are. We love boxes when whether we're defining people or we're defining things, right? So, one interesting example is like when people are climbing Everest. Over 8,000 meters is called the death zone, right? At about over 8,000 meters, we call it the death zone because, your body starts dying at that point very quickly. But it's not like you're perfectly safe at 7,950 meters and you're all of a sudden dying way faster at 8,050 meters, right? Or the way that our atmosphere slowly dissipates, right? There's really no line where our atmosphere ends. It's at 100% at one point, then it's at 90%, and then it's out to 10% and 1%. And humans made this line called the Roche limit, I believe is what it's called, where we decided that is where the atmosphere ends, right? But technically, there's still a little bit of atmosphere out past that point. And so this is just to say, like I said, we like to do the same thing with race. I'm not going to get into that. But, like I said, humans like to kind of create categories and put things in boxes because we like to recognize patterns. Pattern recognition is a way that we evolved. It's a way that's helped us throughout history, right? So, and if you've never read Malcolm Gladwell's book, The Outliers, he talks about this quite a bit. But I'll save that for a different video. But yeah, so this is from the Soho, October 15th through 26th. So we are getting new images there. Like I said, this is stacked up from November. This is really awesome. So this is the Virtual Telescope Project 2.0, remotely controlled robotic telescopes online. So they successfully imaged 3I Atlas after its recent conjunction with the Sun, starting out I'm assuming that's supposed to say out, post-perihelion, observing a season of this extraordinary object, looking forward to show it live to the community. I don't think that was an English first speaker that wrote that, but that's fine. So let's take a look at this full image, loading up like it's AOL. Yeah, so, like I said, not as really brilliant and amazing looking as Lemon. But again, if you were an alien spaceship, would you want to be all bright? So this image comes from the average of two 120-second unfiltered exposures, remotely taken with a Celestron. Ooh, I have a Celestron, but this is a way bigger and more expensive one. I think that's a 14-inch mirror. Robotic unit available as part of the Virtual Telescope Project in Italy. An extremely bright moon was setting, with the target just 8 degrees above the eastern horizon, almost at nautical twilight. The cometary diffuse nature of the object is obvious. The bright star southwest of the comet is Gaia DR3, with a magnitude of 11.76. Beautiful. All right, so now that we're done with the 3i Atlas update, I wanted to get into something really interesting, which is the United States return to the moon. And I actually thought that Veterans Day would be kind of a fun day to do it. So pictured here are the 4 astronauts that have already been picked to go to the moon. But I wanted to start out with just a little bit of a history of why has it been 50 years since we've been to the moon, nerds? Like, let's be real, and a lot of conspiracists are like, well, we can't make the technology anymore. We're going to get into all of that stuff. We're going to get into theories of if aliens told us off or whatever, all that kind of fun stuff. So let's just get into it. But in 1972, the end of the Cold War, when Vietnam and Watergate slashed NASA's budget. So right before this, at the peak of the Cold War, and when we were competing at the space race with the Soviet Union, NASA's budget was 4.5% of the United States' GDP. This was in the 60s. Okay, right now, NASA's budget is 0.5% of the United States GDP, and it's spread over 25 plus missions. You're talking about maintaining the JWST, the Perseverance rover, the Europa Clipper. Okay, so it's a lot less resources spread far more thin, and that's why it's important for you guys to share videos like this with your friends and try to get them excited about science. That's why I like talking about aliens and kind of fun stuff sometimes because, interest is important, because if there's not interest in science, there's not interest in outer space, then there's not political will and money doesn't get allocated, right? So it is important. a lot of people nowadays kind of have more of a fix Earth first approach sometimes, right? Where it's like, Elon Musk is this rich guy. Why is he spending all of this money trying to get to Mars when there are poor people here on Earth suffering, right? So, Pew polls about 50% say climate and poverty is more important than space. So, if there's no urgency, then the inequality in the budgets can spike. Um, and sources for that, it's Planetary Society GDP charts, Pew 2024 space poll. So, then we get into Operation Paperclip, which is interesting. And I'm not going to get into this super deep, but this isn't a conspiracy. It's a real thing that happened. At the end of World War II, when the Soviet Union and the Axis powers were sort of disbanded and we did the Treaty of Versailles, the U.S. grabbed 1,600 Nazi scientists. And Werner von Braun was one of them, right? And so Werner von Braun, he was the V2 terror daddy. He designed these deadly V2 rockets for Nazi Germany. And then the US picked him up. Now, to be fair, I will say that if you're a scientist in like a despotic country, a lot of times you might just sort of be picked up and told by the government that you are going to work on this project and you don't really have much of a choice. So I haven't looked into von Braun's history very much. I've heard he's not a very good person. But we sort of just looked past it. And like I said, it's not every day that you just grab up 1,600 scientists from another country. So start putting that together, right? We were spending a lot more of our money going to the moon in the 60s, and then all of a sudden we grab up, we just had this extra surplus of some of the world's best rocket scientists. So, that's pretty important, I think. Now, I have heard a theory that we couldn't rebuild the Saturn V rocket if we tried. And if you're unfamiliar, the Saturn V is the massive behemoth rocket. It could fit like 14 people. That's the design of the rocket that we used for the Apollo missions. And it was just absolutely huge. And so people always ask, why don't we just make that ship again? Like, it works so well. It's massive. It's great. And it's complicated. So a lot of people will just tell you that, oh, NASA lost the technology. And while that's not 100% true, there is some truth to it. Because, like I said, all of those scientists that we got in Operation Paperclip, they're not around anymore. The blueprints do exist at NASA, but they're in vaults and they're mostly on paper. Some of it's been digitized, but it's all kind of separate. And then on top of that, if we could get all of these blueprints together and get some really smart scientists together and rebuild something very close to it, which we probably could, would we want to actually build the Saturn V rocket again? It would cost about $1.2 billion a launch. It's insanely wasteful, no reuse. It was a kerosene guzzler. So just by today's like political and kind of green energy standards and all of that stuff and trying to be less wasteful, we just have so many like Starship's relandable rocket, or SpaceX's relandable rockets are just leaps and bounds ahead, and we need to kind of keep putting technology into that. So, if you hear somebody say, "Oh, we just lost the blueprints," it's kind of a little bit. Um, but yeah, just very interesting though that. Like I said, unfortunately, I don't like to do politics on this channel, but unfortunately, there is always an intersection where politics meets everything. And, if you're a science enthusiast, scientist, or anything like that, we should always be looking to try to engage the public's interest so that we can, be helping to get more funding for things, right? So, that brings us back to our Artemis update. So we had an uncrewed November 2022 successful mission. So the Orion did a moon loop. Its heat shield kind of had a little bit of issues, and they fixed that post-testing. So next, what we have scheduled is a crewed flyby in September of 2026. That'll be 4 astronauts, Wiseman, Glover, Koch, and Hansen. So that's these 4 right here. These are going to be our 4 astronauts. The commander, the pilot, and the mission specialist. All right. And if you're interested in this is just nasa.gov/missions/Artemis 2. So this is the shuttle. But yeah, so in February of 2026, the four astronauts are going to be going on a 10-day, 1.3 million mile loop. They're not going to land on the moon on this trip. They are just going to go to the moon, loop around it, and come back. So that's going to be in February 2026. We kind of have to hit that date because of conjunction, but I do just want to note that NASA does sort of have a history of delaying these things. Artemis has been delayed in the past. I think they're actually kind of getting close to ready now. So, like, fingers crossed there's no delay, but, you know, I don't work there. Don't quote me on that. Um, and then Artemis 3. So Artemis 1 was the uncrewed one in November 22nd. Artemis 2 is the crewed flyby that they're going to be doing in February of 2026. And Artemis 3 is going to be when they actually land on the moon. So Orion into lunar orbit. Starship is going to drop two crew and a taxi, not a lander. And there's going to be about 30,000 jobs tied to this. It's a SpaceX and NASA collaboration, just like your favorite rapper. So, I mean, I actually think it's going to be really fun. And I like seeing government and private industry working together. I'm really happy that SpaceX was able to just be like, hey, why aren't we re-landing rockets, dude? Yeah, so let's take a look at this. So this is going to be the Artemis 2 mission. This nice detailed step-by-step. So they're going to launch, jettison, core stage main engine shut off, perigee raise maneuver, apogee raise, burn to high Earth orbit. And they're going to be doing that'll begin the 23.5-hour checkout of the spacecraft. Then the Orion is going to separate from the propulsion stage. Then the upper stage is going to separate. Then they're going to have the perigee raise burn, translunar injection. So now we're at number 9. So that's here. Outbound transit to the moon. Do a little lunar flyby. Check out the far side of the moon. Make sure there's no aliens there to tell us off, because, that is another theory that's why we didn't return to the moon, is because, the aliens told John Glenn, hey, this is our moon. All right. And then it's going to come on back. Trans-Earth return. Crew module separation. And entry interface. And splashdown. Into the ocean. All right. So, and I just did want to note too that another reason why this is kind of taking a lot longer is because we test things a lot more. Safety is a lot more of like an important thing nowadays. Politically, you can't just kind of send a bunch of people to the moon saying, yeah, maybe they'll die. Hopefully we get it right. We were able to do things like that in the Cold War because they were able to sort of use the excuse of competition and that, like, we have to get there first. It's dangerous, but these guys are heroes, and so let's just send them there. Today's climate, no, people aren't just going to let you send 4 people to the moon on like a 30 or 50, 70% chance they might die because we haven't been to the moon in 50 years, right? So we've been doing a lot of testing. That's another reason why it's going to take a while. Take a look at this. Page not found. You suck. But yeah, so there you go. So 3i Atlas getting close to Jupiter. Hopefully we'll get some better images of it, but I wouldn't really cross my fingers. Hopefully we get something from the GOES satellite or some of the instrumentation on Jupiter. But we'll see. But the good thing about it is that we were able to observe it coming in. So as far as observations, and like I said, there aren't really any really brilliant, beautiful looking images, but as far as the data that scientists are getting on it, it's going to be amazing. And, if you know anything about kind of how astrophysics works, a lot of times there's a lot of data and just not enough people to process it. And by the way, amateurs can process and try to find things for the government all the time by just searching through archives and telling them that you found something. But so I would assume that for the next few years, we're going to be continuing to kind of analyze this data and learn more and more about 3i Atlas. And then, like I said, just to summarize why we didn't go back to the moon, guys, it's mostly political and financial will. And just the fact that, like I said, we're not in this Cold War race. We don't have 1,600 free scientists that we just snatched up from some other country. The world's a different place now. And money is also tighter, spread across way more things. Like I said, we have giant space telescopes out there now that we didn't have back then. So, the moon missions were really the bulk of all of this 4.5% of GDP. So we were able to just kind of spend, like I said, what would equate to like billions of today's dollars, just to try to get to the moon. And like I said, we are going back with the Artemis mission. The next flyby, and I said this would be Artemis 2. This is going to be happening in 2026 in February, as long as there's no more delays. So I'm really excited for this. I think it's going to be awesome. I can't wait for the U.S. to return to the moon. China and UAE, I believe, are already there. And, we're doing a lot of stuff on Mars. We're doing a lot of stuff in other places. But, if you've watched any of my Mars kind of documentary videos, I did like kind of a 6-part documentary about it before I started just going live every week. And one of the things that I always said is that, like, if we're gonna ever stand any sort of a chance of colonizing Mars, and like I said, if I ever had a phone call with Elon Musk and had a chance to talk to him, I would tell him to just redirect all of his energy from Mars to the moon, because the moon is so much closer. We can launch rockets with like 1/6 of the energy, or launch a rocket like 6 times larger with the same energy from the moon because of its low gravity and its basically lack of atmosphere. And honestly, if we can't build like little bubble domes and survive on the moon for a while, where it's closer and we can send resupplies way faster, we ain't gonna be able to do it on the moon, guys. So, and whatever country can kind of develop some sort of a foothold on the moon may also develop in a severe, extreme strategic advantage as well. So, I don't want to get into that too much. I will just let your imaginations ride with that. But yeah, so let me know what you guys think. Why didn't we go back to the moon? Did aliens tell us off? Is it something else? Is it just the technology? Is it just the lack of will and financial power, as I said? Or And then let me know what you think about our future missions to the moon. Like, do you think it's going to get delayed again? Do you think we're on track? Because it is a collaboration between NASA and the government, so they have to be kind of keeping pace with each other, coordinating, more bureaucratic red tape. So let me know what you think about that. And then let me know what you think about 3i Atlas. Are they hiding images from us? Is it just not super bright? And is it just a space rock? All right. Well, this has been Matty Adams. I really appreciate everybody for stopping in. This is the first time I did this on Facebook. Like I said, TikTok, I'll be able to share my screen like I do on YouTube soon. I have to go live a few more times and stuff. So anyways, all right. Thanks everybody. I'm going to start turning off all of my devices now. I appreciate you for coming in. Bye.